Alright, this section is all about congruent triangles. Okay, now we've talked about what congruent means a little bit before, okay, but congruent is basically just same shape, same size, okay, the exact same figure. Now, what we're going to look at today is the idea that this means all corresponding parts of the triangles. This means that all three pairs of sides and all three pairs of angles are congruent. So if we look at this example here, okay, we've got triangle ABC and triangle FED. Right? To write a congruence statement, to show that these two triangles are congruent, that they're the same size, same shape, we need to match up corresponding parts. Okay, so corresponding parts are the ones that are equal. So in this case, okay, we've talked about these little marks before too, right? If I've got the same number of marks, that tells me that those two sides are congruent. So in this case, AB and DE have the same length. BC and EF have the same length. And then AC and FD have the same length because they have the same number of marks on the sides. You do the same thing for the angles. Okay, the angles have the same number of arcs. So A and D have the same measure. B and E have the same measure. And C and F have the same measure. So when we're writing a congruent statement showing the two triangles are congruent, we're just matching up corresponding pieces that we know are the same. Right? So what they said in this statement, they said that A and D have to be the same angle. And they are, right? They both have one arc. They're saying B and E have to be the same. They are, right? They both have two arcs. And they're saying C and F, have to be the same because they have the same number of arcs. Right? So there's actually more than one correct way to write a congruent statement. Okay? So this is one example. But we could also say, if I jumble the letters in my first triangle, we could say triangle BCA is congruent to how we have to match up the corresponding pieces. So B, since it has two arcs, matches up with E. So to write my statement, I'm going to put E first over here. Then we said C. Well, C has three arcs. That matches up with F. And A has one arc. That matches up with D. Okay, so this would be another example of a correct congruent statement. Okay, and we could write more. Right? There's a lot more examples of correct ways to write a congruent statement. We're not going to go through all of them. Okay, but there are a lot of correct ways to do it as long as we're matching up the congruent corresponding pieces. Right? So, an abbreviation for this idea, CPCTC. Okay, we'll work with this idea a lot more in the later section. Okay, but CPCTC stands for corresponding parts of congruent triangles are congruent. Okay, so what this means is if I know two triangles are congruent, then every pair of corresponding parts has to be congruent. Okay, all three pairs of sides and all three pairs of angles. Okay, guys, what are we doing on our computers here? Okay, so if I'm just given a statement like this, okay, a congruent statement for two triangles, I can get every pair of congruent angles and every pair of congruent sides out of just that statement. I don't even need a picture. Okay? If I want to match up the corresponding angles, I just look at the order that these are written. So J and P would have to be the same. So if I want to say, what's a pair of angles, I can say angle J is congruent to angle P. Then I just look at the next one. Angle K and angle Q. I know those are going to be the same. And then the last one, L and R. So angle L is congruent to angle R. Just from the statement. Right? I don't even need a picture. I know all of this information just from how this congruence statement is written. I can do the same thing for the sides then. I can say side JK is congruent to side PQ, okay, just from the order that these are written in. So the way we write that, right, is saying this segment is congruent to this segment. Okay, segment JK, segment PQ. Well, then I can say segment KL and segment QR. Those two sides are going to be congruent. KL and QR. And then the last combination, right, would be the first and the last letters, right? Side JL and side PR. So, I mean, we could draw out these triangles like they had it drawn out up there in the top example and see that each of these pieces would match up, but we don't even need to do that if we're just given this statement. Okay? Questions? Right, so then, okay, at the bottom it says write another example of a valid congruent statement. So I just want to change the order. So I can make the first triangle whatever order I want, right? I could say LJK. I'm going to say triangle LJK. So now, I just want to match up the corresponding pieces in my second triangle. So L matches up with R, so I'm going to put that first. Then J matches up with P, and then K matches up with Q. So this would be an example of another valid congruent statement. And there's more correct ways to do that as well. Questions? All right, you guys try number 2 then. Okay? Write me the 3 pairs of congruent angles, 3 pairs of congruent sides, and give an example of another valid congruent statement. All right, these are looking good as I'm walking around here. So now there's multiple correct answers for the last part here. So somebody give me a way that you wrote another congruent statement for the triangles. So triangle YXW. Yep, that would work. Triangle YXW is congruent to triangle GFE. Right? Somebody give me another way that they did it. Triangle XYW is congruent to, well, you said XYW. So if we did XYW, we would need to do FGE. Because X is in the middle, so we would have to start with F. Then Y matches up with G. And W matches up with E. So triangle XYW and FGE would be another correct way to do it. Okay, and there's even more correct ways to do it. Okay. Questions? All right, then. Yeah, yep, we're good so far. So now, if we look at the last example on the front here, they give us a congruent statement, and they give us some pictures, and they just want us to give the corresponding piece that's congruent. To do this, we actually don't even need the picture, right? All we need is the congruent statement itself. So if I say, well, Km, so if I go to my triangle congruent statement, Km would be congruent to AC, and I'm just looking at the corresponding pieces. So I don't even need the picture, right? I'm just looking at the statement. And they say CY, so that would be CY, that would be congruent to MP, and I'm just looking at the statement and matching up corresponding pieces. I think looking at the picture might just make it more confusing, right? Because sometimes it's hard to tell which pieces are the same length or which angles are the same size. Just looking at the statement is the best way to do this. So why don't you guys try to finish this out real quick here? Okay, give me the corresponding congruent pieces, pieces here. So this one, it's, oh, no. Oh, yeah, I was looking at the other one. No, yeah, I was looking at this one. YAC. So YAC should be PK. Yep, perfect.
Pretty sure I did.
How's this? Each missing measure. No.
All right, I think these should be our answers for number 3 here. Okay, just matching up corresponding pieces. Okay. Any questions on this stuff? All right, then let's flip over to the back and start throwing in some measurements. Okay, so if we look at these examples here, okay, we're told triangle STW is congruent to triangle BFN. So before I even start trying to fill in information over here, I'm going to mark this on the diagram. Okay, so I know that S and B correspond. So I'm going to say S and B match up. I'm going to put the same number of arcs in those spots. I know T and F match up. So I'm going to put the same number of arcs in those spots. And I know W and N match up. So I'm going to put the same number of arcs in those spots. Okay, just so I can visually see what matches up. Okay, then I can do the same thing with the sides. So I can say ST and BF match up. So STW and FN are the same. So I'll put the same number of marks on those. And then I know SW and BN are the same. So I can say 1, 2, 3, 1, 2, 3. So that just lets me see quicker on the triangles themselves which pieces correspond, okay, which pieces are equal. So for these, we actually want to give the length of the side or the measure of the angle. So if I look here, I want the length of BN. Okay, well, I don't have that. But I know that BN is the same as SW. Right? So I know that BN is going to be 9. Okay. Now, I want the length of TW. Well, I don't have that. But I know TW is the same as FN. So TW is going to be 14. Now I want BF. Again, I don't have that, but I know it's the same as TS, so 17. Right. Now I want to do the same thing with my angles. I want angle W. I don't have that. But I know that's the same as angle N. So that's 82 degrees. Now I want angle B. That's going to be 67. Yeah, so if I look at angle F, I know angle F matches up with angle T, but I don't have either of those. How can I find that?
180 minus 82 minus 62. 67.
Right. I know that all three angles in the triangle are going to add to 180. I know two of them, and I know they're 82 and 67. So using what we talked about in the last section, we can say 180 minus 82 minus 67 is 31. Okay? Be okay with that idea? Okay, so take a couple of minutes and try number 5 here. Okay, give me the lengths of these sides and the measures of these angles.
Total of how to do it.
She is not actually pretty. No way. No, she looks like poop. 5 out of Jim Phillips.
Wait, which one?
Oh, she looks like. Huh? Ooga booga. Shank.
Hey, slip. How about him, Mr. Pat?
What's up?
Look at this dude. Really? What is that supposed to mean? Why would you put that there?
Well, they tell us that these two sides are the same, right? With these markings.
Right.
So if I know this is 27, that one's 27.
Yeah, it's common sense. But I don't have much common sense, obviously.
I didn't know that either.
Just fine.
So I do 180 minus 27 minus 27, and I get G and J.
So that's for the angles, right? So 27 are the side lengths.
Yeah, I don't know how to find angles.
So you're only given one angle, right? Yeah. So how do I find that? Two missing.
Would you subtract 38 from 180 and then divide that by 2?
Yeah.
Because it's a triangle.
The only reason we do that is because I know these two sides are the same. Yeah.
Sad. The triangle's sad. Look. It's got two eyes and a frowning face.
And a really big forehead.
Right.
Well, so what we're wanting to do on these, like we did up here, is give the actual measure. Yeah, it's finding just a bit. All right, let's talk about number 5 here. Okay. If I look at triangle GHJ, I'm told through the markings on the diagram that these two sides are the same. So I'm told this one's 27. That automatically tells me this one's 27 as well. Right? So that means that the corresponding sides over here in triangle XYZ would also be 27. So both of these are going to be 27. Right? So if I want to fill in my sides, okay, I can start with GJ. Well, GJ matches up with XZ, so that's going to be 18 feet. Then XY, we said, is going to match up over here with GH, so those are both 27 feet. Then ZY matches up with JH, which is also going to be 27 feet. Right? Well, now, if I want angle H matches up with angle Y, so those are both going to be 38 degrees. Right? But now if I look at my next two, Z and J, okay, so Z would match up with, well, Z matches up with J, and then X matches up with G. I don't know any of those angles. Okay? So this is actually a small idea that we haven't quite touched on yet. But if I know these two sides are the same length, the angles opposite them will be the same. Okay, so if these two sides are the same, these two angles will be the same as well. So what I can do here, to find these two missing angles, I can take 180 minus 38 and then cut that in half. Okay? So 180 minus 38 is 142. So I know both of these angles would add to 142. Then I can cut that in half and get that each of these is 71. Okay, so both Z and J will be 71 degrees. What's that?
How did you get 71?
So what I did was said, well, if I know these two sides are the same in my triangle, that means these two angles are the same. So if I want to set up an equation, I can say that they're both x, right? If they're the same, I can say they're the same variable. So I'm going to add them, so it's going to be 2x. So if I add all three of these things together, x plus 38 equals 180. So x plus x is, we said it was 2x. So yeah, subtract the 38 over, and then divide it by 2. Get 71.
Because I'm not gonna lie to you, what I had did is when I got to E, I just put my thumbs down and
Does that make sense, though?
yeah, I can definitely see it.
All right, cool. So then our last idea for the day is down here, 6, 7, and 8, where we want to set up and solve equations for variables. But we're going to be doing the same process here. So, I want to set up and solve equations for x, y, and z. I need to make sure I'm matching up the correct pieces. So just looking at the diagram, it's almost impossible to tell which sides match up, because these sides are almost the same length. I have to use my statement, right? So if I want to solve for x first, x is side uv. So if I go to my statement, uv matches up with ts. So this side here, uv, is going to be the same as ts. So I can say these are equal to each other. I can set up an equation as 12x minus 7 equals 53. Yes. Okay, so then to solve, you would just add the 7 over, divide by 12, and x would be 5.
You gotta go so fast.
No,
Is that too fast?
No.
where's that 53?
So I decided to solve for x first, right? So that's side uv. So I went to the statement and said uv matches up with ts. So over here, ts is 53. So I can just set those two things equal to each other. Okay? Questions? Okay, so why don't you guys try W and Z here? Okay? Set up an equation to solve, did I say W? Set up an equation to solve for Y and Z. Okay?
No.
Find which side corresponds to RS over here, then find which side corresponds to UW over here. Set up and solve your equations.
Why did you say UW?
So UW is where Z is.
Oh, that's good.
So you're going to set up an equation to solve for Y, and then separately set up an equation to solve for Z.
What?
So you're going to have two different equations.
Hey, I got a question.
So,
Will I do 5y minus 33 equals 53?
minus 33. So that's side RS. So if I go up here, RS matches up with WB. So that'll be this one.
So I have to do 5y minus 33 equals 57.
You know that equation is
5y minus 33. Well, so if we go to the statement, that's side RS. So RS matches up with WB. So it'll be 57.
You want me to see what I did?
Yeah, that's good.
What's 90 divided by 5?
18. What's that? Yes.
So is it y equals 18?
Yeah.
Yep.
I mean, even if you didn't remember that,
One of them is 80.
Yes, sir.
So I got the Y. I don't even know the Z yet. Alright. Does that match up with
Jesus, you freaking magician!
Oh no,
Yeah,